All right, so this is all about 1-6, absolute value equations and inequalities. Our objective today is to write and solve equations and inequalities involving absolute value. So today we're just going to get to the equation of absolute values. Next week we'll cover the inequalities part of it, okay? So I started you out let's forget those for right now. We're going to focus on 71 and 72 for time's sake today because I want you to have some class time to work these. So if you had plenty of time, so let me see on your whiteboards what you got for 71. And I'll write down the things that I see. You don't have to solve the whole thing, just give me your answer, okay? Oh, I'm seeing the same thing over and over. Everybody's got the same thing. Everybody. I still have 2 without. I have 7a plus 5, good. And then one that might possibly be lost, so everybody look up here. Let's see if that's correct. So I think I did this on the next one. Is that one? 2a minus 4. Yep, that's it. All right, so let's see how we do this. Well, if you were following PEMDAS, we would say, well, parentheses first. And inside the parentheses, well, there's nothing we can do here because those are not like terms. So parentheses, what did they do? They just grouped that together, but there's nothing we can do with it. And same thing over here. It's grouped together, but we can't combine 5a and 9 because they are not like terms. So we're just now going to say, well, we looked at the parentheses. There's nothing we can really do, so we're going to remove the parentheses and move on. That's if you're following PEMDAS. All right? Now, we're going to just look at what we have. We've got add and subtract from left to right. So let's just combine our like terms. So we've got a 2a and we have a positive 5a. So you can rewrite them if you need to do that step. If you leave that step out, it's no big deal. And then we've got these two terms, negative 4 and 9. So I'm just regrouping by like terms. So I have my a's together and my constants together. All right, now let's do that. Let's combine the like terms. So 2a plus 5a is 7a. And 9 plus negative 4 is a positive 5. So everybody got it correct. Good job. I would say, are there any questions? Are there any questions? You all got it right, but you can still have a question. I won't shame you for that. All right, let's look at the next one. Now we have 3 times the sum of x and 3y minus 5 times the difference of x and y. So I think I wrote that. No, I did not. I was down here. All right, so let's write this one on the board and let's see what you guys have. I have a negative 2x plus 14y, and I have a negative 2x plus 4y. I have a negative 2x plus y, and an 8 plus 4x. That was good. 2x, good. Negative 2x was 14y. And, all right, I think I've, oh, here's a negative 2x minus 14y. All right, so a lot of things to choose from. So this is definitely one we need to cover, okay? So let me copy this and go below. All right, so the first thing we need to do is we have to follow that PEMDAS. We have to distribute first, right? There's nothing we can do inside the parentheses. So there's no exponents, but there is multiplication. There's this multiplication and that multiplication, actually, that multiplication, right? So let's do the distribution first. So 3 times x is 3x, 3 times 3y becomes, and it's a positive 3y, so positive 9y. Is everybody with me to there? All right, so the next step is to take this negative 5 and distribute that to these two terms. So negative 5 times x becomes negative 5x, and then negative 5 times negative y, well, negative times negative creates a positive, and 5 times y is 5y. Okay, so is everybody with me to there? Any questions about any of these so far? And this is why it's a good idea not to erase anything on your paper. Just follow along and see if you can pick out where you might have made your mistake. Or rewrite it the right way and take it home and decipher where did I go wrong with this. So the next thing, again, we're going to take these like terms. Here's my x's. So I've got a 3x minus 5x. And then I'm just reordering. 4y plus 5y. Okay, my next step would be to combine my like terms. So this combines to negative 2x, and this combines to 9y. So there's your answer, negative 2x plus 9y. And let's see if anybody had that. I don't think that was one of our, oh no, did I clear it? I guess I cleared it by accident. Sorry, I did. So did anybody have that? Negative 2x? I don't think that was one of the choices. All right. Where are my things? Up there it is. Okay? So it's negative 2x plus 9y. Are there any questions about that? And if you did get it wrong, do you see where you went wrong? So make sure, my thought would be the distribution threw everybody off because that was the only new thing here. Or maybe you did not watch this sign and you just did a 5x and a negative 5y and you just, that was ignored and it changed to a y. Yes? Oh, I erased the top of that 9. Thank you. Okay, let's go back. I was like, what? So sorry. Okay, so when I erased earlier, I erased the top of that 9 and took it for a 4. So let's fix this real quick. So everywhere I had a 4y, that's a 9y. So that changes this to 14y. I'm so sorry, guys. Thank you. You get to pick out of the goodie box. So it's negative x plus 14y. I wondered how, there were so many of those, I was like, how did, everybody must have made the same mistake. All right, so is everybody in agreement now? Thank you. All right, so I'm going to give you the goodie basket and let you pick something from there for catching my error. But I did, I erased the top one of that 9. So you can pick from here, or you can pick from these. There's protractors, there's sharpeners, I even got the toothbrush and toothpaste, erasers, protractors, sharpeners, and there's staplers. And this is these and that. Like you said it. Or something. Protractor? Okay. Very good. Thank you. All right, so this is the way I like to operate, especially if you catch one of my errors, you get to pick something from the goodie basket. All right, donated from the pencil box. Thank you, pencil box. All right, any other questions about this one? All right, thank you, and especially thank you for catching that error that I erased the top of that 9 and thought it was a 4. All right, so today we're going to talk about absolute values, and I'm going to show it my way. Was that the door? Was someone knocking, or was that you bumping on something? I thought I heard someone knock at the door.
I think it was just us.
Okay. Well, if it knocks again, let me know. if I don't hear. Okay, so if I talk about an absolute value, when we worked in, let me erase that, in Algebra 1, you would see something like this, or you would see something like this, or maybe like this. Okay, this would represent the absolute value of x. We represent, the symbol for absolute value are these two bars with some expression inside. It could be a constant number, it could be an algebraic symbol, or it could be a combination of all. It could have 15 terms in between there, the bars. So whatever's between here, that means I'm taking the absolute value of what's inside these two bars. So this would represent the absolute value of x, this represents the absolute value of 3, and we'd say that would represent the absolute value of -6. But how do you work these and what do they mean? What is an absolute value? If I have, absolute value is nothing more than a measurement. It's a distance. So if I tell you I'm going to measure something, can I say that the length of that is -6? Can we have a negative measurement? No, not unless if we're crunched up in a black hole somewhere being warped by time and space, right? And that doesn't exist in our Algebra 2. That's what, quantum physics or something? So for our examples, when we talk about absolute value being a distance, it means it's going to have a measurement. It's going to be a positive number. So if I say, what is the distance? How do we measure this distance of an absolute value? Well, it's how far is this number from 0 on a number line? So if I ask you, how far is, actually let's just start with a positive. If I give you a number line, it goes on forever and ever, and I have 1, 2, 3, and -1, -2, -3. If I ask you to show me the value of 3, the absolute value of 3, excuse me, it means how far is this thing between the bars, number 3, which I'll mark it right here in blue, how far is that from 0? Well, you would say, well, there's 0, so this number 3 is 1, 2, 3 units from 0. So you would say the absolute value of 3 is 3. All fine and dandy. Thumbs up if you're good with that. Thumbs down if you're wishy-washy. Okay. Now, what if I throw, I'll try not to erase the tops of anything. I love that you guys keep me on my toes. All right, so if I give you, what's the absolute value of -3? Well, let's first graph -3 right here. How far is -3 from 0? You're going to say 1, 2, 3. -3 is also 3 units from 0. That's all absolute value is. It's how far is whatever inside here, how far is that from 0? So some teachers may have taught you, well, when you were first learning it, well, if there's a negative sign in there, just strip the sign. But you need to understand why you're stripping the sign. It's the measure of that number to 0. So -5, the absolute value of -5 would be what? 5 units. And if I had the absolute value of -23, what would that be? 23. It's 23 units from 0. Even though it's in a negative direction, we're still just measuring distance. How far are you from 0? On either side, the positive side or the negative side. So if I gave you something like this, and let me choose a smaller number. Okay, so let me make my number line here. If I ask you to graph this, what can x be? Say that louder.
-2 or 2.
You are correct. -2 or 2. Because the absolute value of -2 is 2. And the absolute value of 2 is 2. They're both 1, 2 units, 1, 2 units from 0. So yes, if you put a variable in there, it's going to have 2 answers. Do you see that? Because it could be a positive 2, x can equal a positive 2, or x can equal a negative 2. And that's your answer. You might see people rewrite that as x equal positive negative 2. When you have the positive, actually that looks like an upside down cross. It's supposed to be a plus sign and a negative sign. That didn't look much better. But you can combine them into one answer, positive negative 2. And that replaces doing x equals 2 and x equals negative 2. All right, any questions so far? All right, now what happens when we get more than one thing in our absolute value symbol? Whoa. Okay. Well, that's now something that we've got to work with. And you did this in Algebra 1, you might remember. So if we get this, we know that this is going to be a positive, the x is going to represent a positive and a negative number by the nature of the beast, right? We know, because there's a variable, it has to have 2 answers. So how do we figure out what 2 answers those are without getting down a pencil and a paper and making a bunch of little scratches and jiggles and counting? So what we do is we solve this. The first step is just make sure that the absolute value is isolated on one side of your equation, which it is. There's nothing else here but the absolute value equation. And now we're going to solve this 2 ways to get our 2 answers. We're going to solve it as a positive 5, and we're going to solve this as a negative 5. So let's do this. X minus 6 equal 5, and x minus 6 equal negative 5. And this should give us both of our answers. So let's do that. So add 6 to each side, and we get 11. X equal 11. So there's one answer, possibly. Now let's solve this side. Add a positive 6 to each side, and you're going to get that x equals 1. So these should be our 2 answers. But how can we be sure? Well, you plug it back into the original equation and see if it makes a true statement. So we've got x minus 6 equal 5. So we said the 2 answers were 11 and 1. So we're going to check this. So let's plug in our 11. And when you're checking, be sure to put a question mark over your equal sign. So I'll do another line there. So this is my checking part. So I'm going to check, does the absolute value of x minus 6 equal 5? Well, let's see. Well, 11 minus 6 is equal to 5. So now the absolute value of 5 is 5, and 5 does equal 5. So yes, 11 checks out. He's good. It made a true statement. So definitely one of the answers. Now let's do the same for 1. So now we're going to have 1 minus 6 equal 5. Does it equal 5? So now 1 minus 6 is going to be negative 5. Well, the absolute value of negative 5 is 5. And 5 does equal 5. So yes, it checks out also. So we not only solved it both ways, we proved that's the answer. Now, how do we graph this? Well, again, you're going to do one number line, and you're going to put a dot on 11 and a dot on 1. So we'll put negative 1, 0, and then let's just go 2, 4, 6, 8, 10, 12. So 1 would be there, and 11 would be here. I probably should have done negative 2. All right? So there they are. So 1 and 11. Any questions so far? So you've learned how to solve a simple inequality equation and how to check it and to graph it. Okay? So let's move on a little further. So the first problem, and this is a lot like what we just did, but it's just a little more to it, so we'll work through this pretty quickly. What is the solution of the absolute value of 2x minus 1 equal 5? Graph the solution. So the first thing you want to do is rewrite it as two equations. So let's see, 2x minus 1. Okay, so rewrite it as two equations. So we're going to go 2x minus 1 equal a positive 5 and 2x minus 1 as a negative 5. Okay. Now solve both sides. So again, use your solving skills. So add 1 to each side, and we've got a 6 over here. And then divide each side by 2, and you have x equal 3. Over here, add 1 to each side, and we get a negative 4. Divide each side by 2, and you get a negative 2. So x equal negative 2. So we have both of those, and I hope you don't mind that I'm not showing all those steps. I did talk through it, but I didn't write them all down. And if you need me to write them all down, just don't hesitate to stop me and let me know. I will certainly do that for you. Okay, so there's our two answers. Now, we could graph it at this point, or we should probably check it first, so if it's wrong, then we don't have to go change our graph. But we've got it there and at 3. All right, there's our 2. So now let's get that original equation, absolute value 2x minus 1 equal 5. And let's plug both those answers in and see what we get. So we're going to do negative 2 first. So it's going to be absolute value of 2 times negative 2 minus 1 equal 5. And does it equal? Don't forget your question mark because we're checking. So that's going to be a negative 4. Negative 4 minus 1 is a negative 5. Well, absolute value of negative 5 is 5. So 5 does equal 5. So yes, negative 2 checks out. So he's good. Now let's do the same for 3. So now we've got 3. So does absolute value of 2 times 3 minus 1, does it equal 5? So 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. And 5 equals 5. So yes, it checks out also. So we can say without a doubt these two answers. Oh, I did them backwards. These two answers are correct. Okay, so 3 and negative 2. Any questions? Yes, ma'am. Say that. What, every time we do one of these, do we have to check? It's also 5. That was just coincidence. And the question was, are they always going to be the answer of 5 and negative 5? No. It just, the examples that I picked, and I plucked the one from my head as we were going, and then this first one also had 5. So no, that was just coincidence that both the answers. You're going to get all sorts of answers. Okay. Or actually, those weren't your answers. That was your problem. Yeah, no, it's not always going to be at 5. So let's look at another, and we'll prove that point. So looking at problem 2, here's one where it's equal to 8. So it can be anything. What is the solution of 3 times the absolute value of x plus 2 minus 1 equal 8? And graph the solution. So now they've created a multi-step absolute value equation out of this, because it's not just a simple absolute value on this side and a number over here. Now we're multiplying a number and subtracting a number from that absolute value. So you have to isolate that absolute value like you would have to isolate a variable if we were solving variable equations. So let's look at how to do this. And I think I blew it up. I did. So I've blown this up on the next page. So if you look at this, again, you're multiplying an absolute value sum inside there, and then subtracting 1 from that equal 8. So remember, from the very first thing I said about these is you have to isolate that absolute value in order to solve these equations and remove those absolute value symbols. So the first thing we have to do, we've got to get rid of this and this. Then it would be isolated. So just like solving equations, like I always say, they're on the date, leave them out, they're closer, they're in a hug there, all hugged up next to each other, leave 3 alone. And let's get rid of our tag-along friend, right? -1. So we're going to add 1 to each side. So start there. Okay, and that gives us a 9. So now we have 3 times the absolute value of x plus 2 equal 9. Now we can separate the date, and we can divide by 3. And if I do that, must do that. So those cancel out, and that simplifies to 3. So we're left with the absolute value of x plus 2 equal 3. Now we can solve it. So your first step is to always isolate the absolute value equation. The absolute value part of it on the left side of an equation. All right, so let's solve it now. So it's going to be x plus 2 equal positive 3 and x plus 2 equal negative 3. So we're to remove these symbols, we've got to solve it as the positive and the negative. So there it is with the positive, and there it is with the negative. Any questions on that so far? No, I'm going fast. Yes, sir.
At the very first top of the equation, like the very first, yeah, the black, when you had to add 1, would it have mattered if the first thing you did was divide 3?
It depends on how you divide by 3.
Like divide 3 from both sides, maybe.
Well, it wouldn't be mathematically correct, and here's why. Let me show you. This is actually a whole other lesson, but let me add. Man, that's loud. Okay, so the question was, why did we do this first and not second? Why didn't we do 3 first? Get rid of the 3.
Sorry for the interruption. To all the students that were in the library second hour with Ms. Wilson, please go back to the library at this time. All the students that were in the library with Ms. Wilson
Okay,
this morning, second hour,
so
need to go back at this
your
time.
assignments 1 through 12. Let me talk to you just real quick before you step out. The last problem is when you do your check, sometimes the check comes out not matching. If you did the work right and you put it into the check and the check is wrong, it doesn't check out, that's called an extraneous solution. So I just call it XTS. So for those students who are leaving, that's the last thing that you are not getting, but I am recording this so it'll be out on Classroom. But the extraneous solution is when you do it. Well, didn't I take this up already? Oh, you were supposed to pass it forward. Guys, at the beginning of class, I usually won't accept an assignment at the end of class because it usually means that students instead of watching the instruction, they sit there and do yesterday's work all hour. So if you don't turn it at the beginning of the hour, I will not accept it. And so that's going to be the last one I do. I'm not saying that's what she did because I don't know. I'm sure she's a very good girl. But I called for it at the beginning of the hour. They're always due at in the beginning of the hour, not the end. All right, so very quickly, why didn't I do this first? Because It just depends on the way you do your math. Now, if you want to divide by 3, it means you have to divide every single term by 3. So you would have had to do this. First. Wouldn't that make your problem a lot harder? You could do it. But now you turn this into a lot of fractions that you got to deal with. So if you divide by 3 or whatever you're trying to clear, you've got to divide every single term. It wouldn't be right to do this. Right? Well, actually it is, because this represents 3 times the absolute value of x plus 2 over 3 minus 1/3. These are the same. So you could do that, but you have to realize that you've got a negative 1/3 left over when that cancels out. So you can't just say, okay, this cancels out now. You still have that to deal with. So it didn't cancel out. You got to split it up. You still have the minus 1/3. That's just basic algebra. So these are the things that it's like I'm catching that, okay, we've got some skills that we've got to build up on that we should already be working with. And it's good that you ask these questions because it helps me know how to teach you better and fill in those gaps that maybe your last teacher didn't get to. Maybe you were sick for a week and missed it. So I always say, look at what's closest together. Oh, the multiply is always closer than add or subtract. So leave them. I say they're on the date. They're in the front seat of the car. Leave them out there a little longer. This is your oddball friend or the one that's furthest away. Get rid of that first. Get rid of your add or subtract first, and it will always be easier. So it was, right? If you just add 1 to each side, you're dealing with now dividing this by 3 and dividing that by 3, which gave us a very clean problem. If you had done it the other way, it would have been a lot more tedious fraction work. So did that answer your question?
Yeah, so basically it's the same thing. You get the same answer, but it's more rich.
You would definitely get the same answer, and that's the beauty of algebra. But I know how a lot of the students are really weak on fraction math. Probably if you did it that way, your chances of getting the problem wrong were a lot higher than if you did it the other way. But if you're really good with calculator and can double check your work and all that, you know, it's up to you how you want to do it. But as long as you do your math right, you're always going to get the same answer, the correct answer. Let me show you the last one real quick. I talked about it, but let's look at one. Now, I talked about what happens if you solve it and you get 2 answers. Oh, this one's a little different, right? Now, they've isolated the absolute value, but they have more stuff on the other side. So how do we deal with that? Well, here's how. So we've isolated this, that's correct. But how do you solve that as the positive and negative? Well, you have to put that in parentheses. So we're going to go 3x plus 2 equal the positive 4x plus 5, and 3x plus 2 equal the negative of 4x plus 5. All right, now here there's nothing to distribute on the plus side, so just remove the parentheses and solve. 3x plus 2 equal 4x plus 5. So subtract 4 from each side and you get negative 1x. Subtract 2 from each side and you're going to get a 3. So now divide each side by negative 1 and you get x equal negative 3. So there's that one. On this side, you've got this negative to deal with. So remember, that's just like saying negative 1 and distribute that negative 1 to both terms. So this is going to be 3x plus 2, just copying it down. Now distribute. Negative 1 times 4x is negative 4x, and negative 1 times 5 is negative 5. So you have to distribute the negative across to all the terms. Whatever's over there, put it in parentheses and distribute a negative to all the terms. Now solve. So add 4x to each side and you get 7x, and subtract 2 from each side and you get negative 7. Divide both sides by 7 and you get x equal -1. So there's your two answers. Now when you plug them in to check, and we're running out of time, so I'm just going to show you, it's already worked out up here. When you plug them in to check, you notice that they don't equal. You get the absolute value of -7 equals -7. Well, the absolute value of anything should never, wait, I'm doing a double negative. The absolute value must always be positive, right? It's always going to be some kind of positive number like 5. You can't have the absolute value of x equals -6. That's like saying absolute value of something is a negative number, which defeats the whole purpose of absolute value. Absolute value is always going to be positive. But here, when we do our check with a number we know was correct, that we solved correctly, it checks out to be wrong, and it doesn't exist. That's an extraneous solution, okay? And the other side, the -1 checked out, so it worked. I mean, -1 was correct, but -3 is an extraneous solution. So it'll tell you to solve and state your extraneous solutions. So just circle it and put extraneous, or XTS for extraneous. So work problems 1 through 12, and that's your homework. And we took a little extra time, but your homework's not that much. So bring that back on Monday, and we'll finish the lesson next week, okay?
What's the homework?
1 through 12.
Page.
It's 1-6. We're on the next one. 1-6. We're just going right down the line. All right, any other questions? Thank you, and that concludes today's lesson. Have a good weekend.